Yep. Let's start in. As part of Master AWS Data Engineering, let's understand what are services we are going to cover and what is the purpose of each service. Let's discuss it. So first we are going to start with the fundamental services team. Let's start understanding. So total we are covering 18 important topics team. 18 important topics. Okay. So first we start with the fundamental services. So these are AWS data engineering fundamentals. AWS data engineering fundamentals. So first we start with AWS data engineering fundamentals. Let's say you are coming from uh, cloud background, maybe AWS, maybe Azure, maybe GCP, or you may not coming from cloud background. Let's say you are a Java developer, or you are a RDBMS developer, or reporting tool developer, or you are coming from non-IT background. You need minimum knowledge of AWS cloud before directly working into AWS data engineering, right? So that's why I created 4 modules. First module gives what is AWS data engineering, what is the purpose, what we are going to do with AWS data engineering. There are multiple roles like data ingestion, the ETL activity. ETL again we have ETL, ELT. What is ETL? What is ELT? How we work in AWS data engineering. Okay, how we ingest data from different sources into AWS services. And once the data stored into AWS services, what kind of activities we are going to do? And then what is the purpose of EC2? EC2 is one of the service, and by using EC2, we can create virtual machines in AWS cloud. Like physical machine, we can create a virtual machine in AWS cloud using service called EC2. Before that, how to create account in AWS cloud? How to create account in AWS cloud? What are free tier? How can we utilize free tier to practice our AWS data engineering? Let's say I created an account. Free tier is expired. What we can do? How it will convert? So we are going to discuss all those things, and then very important one is AWS IAM. AWS IAM is very important service in AWS data engineering. Example, let's say we are 5 developers working for XYZ project, and along with us, 2 testers are working, one administrator is working. How to create users? Second one, you created user. What are permissions required to use different services? What is policy? How to create policy? How to assign policy? Next one, we are going to work on different service. Let's say Glue, S3, Redshift. Glue wants to communicate with S3 and process the data and wants to write it into Redshift. How service can communicate with other service? How service can communicate with other service? Okay. And then what is the purpose of IAM here? To one service wants to communicate other service, By default, a service cannot communicate with other service. Then, then uh, how to give access to communicate one service with other service using IAM. Here we have a concept called role. We create a role, we assign role to service. Then a service can get permission to access another service. So IAM plays very important role. So in this fundamentals, we are going to discuss all basic important concepts. So once you complete this AWS data engineering fundamentals, you get a clear understanding of the purpose of AWS data engineering, the purpose of fundamental services. Once you complete this AWS data engineering fundamentals, you will come to know what are prerequisites. Then we are going to discuss the prerequisites. Prerequisites. These are prerequisites. Sorry. So Linux for AWS data engineering, SQL for AWS data engineering, and Python for AWS data engineering, and PySpark for AWS data engineering. So these services we are going to discuss it. So these are prerequisites for AWS data engineering. First, let's understand purpose of Linux. Let's say we developed AWS data engineering application. Then we are going to deploy somewhere, right? Let's say cluster. Cluster means group of machines. They have master, they have workers, and they have a client. So we deploy our AWS data engineering application. Then we need to resolve problems occurred at runtime. Then they give access in client mission for our AWS data engineer, support engineer. Then we need minimum knowledge of Linux to connect with that client, create folders, and give a permissions, etc. At least minimum Linux fundamentals knowledge is required. So we are going to cover that fundamental concepts. Next one, SQL for AWS data engineering. In AWS data engineering, we provide solutions using two approaches. One SQL approach. Second one, programmatic approach. Programmatic, programmatic approach. We are going to use Python programming. Python programming. Eh, Let me yes, through Apache Airflow, friend. I said we can create DAGs using Airflow with Python. I'm going to cover that using Python in Airflow. Yeah. Any questions, team? These are 18 topics I'm covering. You have a unmute option. If you have any question, you can unmute and ask me.
Sir, what is prerequisite for PySpark?
This one. No. Databricks is different. Databricks similar to AWS Glue. Similar to AWS Glue. Databricks, it also generate PySpark. 1 minute. Let me add this point. Databricks is backend, it will generate a PySpark code. It is also used for ETL operations. And this Databricks supports three cloud environments, AWS, Azure, Azure, and GCP. Azure and GCP. And if you want to learn this one, again, this is 45 days course. AWS Databricks on AWS Cloud. Again, it is a 45 days course. Yeah, now you can ask your question. I think someone, yeah, Pranamita. Yeah, it will take, duration is 2 months, 2.5 months. Yes, correct. Yes, 2.5 months means 60 working days, 60 working days, Monday to Friday, Monday to Friday, and 6 a.m. to 7 a.m., 6 a.m. to 7 a.m. Extra, yeah. Weekend, we will plan between 6 to 8. Yeah, yeah, yeah. You can call me Srini or Sreenivasa. Any other? Yeah, yeah. No need. I am covering here prerequisites. All prerequisites I am covering. Whatever knowledge required for our data engineering, I am covering. Linux for AWS data engineering, SQL for AWS data engineering, Python for data engineering, PySpark for data engineering. Minimum 5 to 6 classes. 5 to 6 classes. This knowledge, correct. This knowledge more than enough to work with AWS data engineering and track AWS data engineering. I always say once you complete this one, focus on uh, this two. Focus on increasing knowledge of Python and SQL. I'm going to cover all concepts, but how much required for AWS data engineering? Yes, yes, you will get it. Yes, lifetime. You can contact with admin. You will give clear idea how to get the recordings. The material also we are going to upload into Drive. Yes, correct. Any other questions, Steve? And I forgot to update along with Kinesis. I am going to give one more workshop, Apache Kafka, as a weekend free workshop on AWS. Sure, Pradeep. So Amazon Bedrock is not required. And here AWS provides one special service called Amazon Q. So whenever you are working in, let's say you are writing AWS Glue, you got error. Just click on icon of Amazon Q and you can tell the problem, it gives solution. In AWS Management Console, yeah, how can we write, how can we prompt our problem to Amazon Q? I will explain. Yeah, hey. Uh, yeah, let me add point to your question. So uh, first one, data store. That's so first data generators, data generators like Python, Java applications, Scala applications, Scala applications, and SQL technologies and mobile platforms. These applications are data generators. Data generators. What these data generator or applications will generate data into some data store. Data store. Most of the time, file systems like AWS S3, Azure Blob, and GCP cloud storage. Once data is generated, we come into picture. We means data engineers. Data engineers. We have AWS data engineering, AWS data engineer. AWS data engineer connects this data stores, performs ETL operations, extraction, transformation, and loading. And then we load the data into data warehouses. Data warehouse like Redshift. 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 We process and load the data into Redshift. Now, data analyst comes into picture. Data analyst. Data analyst is responsible to, sorry, data analyst is responsible to prepare reports or dashboards by connecting warehouses. And along with the data analyst, some other people are working like data scientist. Data scientist. Data scientist is responsible to work on huge volumes of data test and predicting features. So in this data world, we come into first person. We are collecting raw data. We are collecting raw data in huge volumes, huge volumes, then then we apply transformations and we load it into data warehouses. After our activity, data analyst or data scientist comes into picture. In data world, I always suggest start your career with data engineering. Then you can choose data scientist and data analyst. You never get chance to go beyond data engineering. You'll get a lot of opportunity in data engineering world. Clear? Any other questions, Steve? You have a option of unmute and you can unmute and ask me. Sure. In AWS, we have a data specialty. You no need any pre-certifications like cloud practitioner, associate, etc. You can directly write data specialty certification in AWS cloud. This course main intention is working in AWS data engineering, not for certification. These whatever services we are going to discuss, those are presented in data specialty, but I always recommend practice different terms before attempting. This course is to work in AWS data engineering real world. Uh, I say take different terms from different platforms and practice. This knowledge more than enough to uh, practice the terms. Whatever we are covering, those are in AWS data specialty. No SQL is not required for AWS data engineer. There are machine learning algorithms, mathematics, statistical knowledge, plenty of concepts. When we try to upgrade our skills, if we do not have feature in our technology, you never get chance to go out of data engineering. So many projects are implementing, going to implement. Data engineer is a key person in data world. Even you never get chance to migrate AWS data engineering with Azure and GCP. So many projects are present in AWS data engineering world. Sure. Mm, mm. Syntaxes are different and UI is different and the style of programming is different. Concepts are similar. You cannot blindly go and work into other data engineering. Syntax is different. Yeah. Concepts are same. Yes. 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 Correct. Correct. Mm, mm. The concepts here, we are going to discuss all data engineering, right? We will master all the concepts in depth. Yeah. That's it for today, team. Tomorrow, we are going to discuss data engineering introductions and what are different other data engineering concepts available. So you are asking DevOps concepts, team. DevOps concepts are not required. Yeah, tomorrow we are going to discuss data engineering introduction. What is the purpose of data engineering, AWS data engineering? Okay. And day after tomorrow, we are going to discuss hands-on demo. Thank you all. Thank you. Yeah. Hello. Yeah. Let's start, Tim. In this session, as a part of AWS data engineering, let's start understanding what is data engineering. It may be AWS, it may be Azure, it may be GCP, it may be Apache data engineering. What is data engineering? So first, data engineer is responsible to collect data from different sources, collect data from different sources, and performs analyze the data from different sources in different formats, and stores the results into either data lake or data warehouses. So let's say we have different data sources like file systems, CSV, JSON, XML, Parquet, ORC, Avro, different file formats, and we may have different RDBMS systems as input or source like MySQL, Oracle, PostgreSQL, etc. Or we may have NoSQL databases like Cassandra, MongoDB as input. We may have different cloud file systems like AWS S3, Azure Blob, GCP Cloud Storage. We may have different data warehouses like AWS Redshift, Snowflake, and different data warehouses as input. First, what we are going to do, we are going to implement data ingestion as a data engineer. This is our first responsibility. We are going to connect different sources, and then if required, we perform we perform transformations. First important point is we need to load entire data into our data lake first. After that, we are going to perform transformations too. In extraction part, connect to sources, then load the data, extract the data, then load the data into data lake. So first we are going to store history of data into our data lake. If it is AWS, we have S3. If it is Azure, we have Blob. If it is GCS, we have Google Cloud Storage. If it is Hadoop, we use HDFS file system to store history of data. Because these cloud file systems, Hadoop file system supporting unlimited storage and parallel processing. It's supporting unlimited storages and parallel processing. So first our responsibility connecting different sources and loading the data into data lake. Once data is loaded, we are going to perform transformations using different technologies. We have different technologies like Python, PySpark, Glue, Databricks, EMR, and different transformation tools. So we are going to perform transformations on this history of data. This transformed data, we are going to load it into targets like data warehouses, like AWS Redshift, Snowflake, and many more data warehousing technologies are available. If it is big data, we have Apache Hive. After transformation, results we are going to store it into data warehouses. So data engineer collects data from different sources in different formats, then performs analysis means transformations and stores the data into targets like data lakes and data warehouses. Let me explain with one more diagram. So this is my source systems and we maintain data lake, data lake, and we perform transformation. We load raw data into data lake, then we perform transformation, then transformed results we will store it into targets like data warehouses. Once our data engineering activity is completed, then data analyst comes into picture or data scientist comes into picture. If it is data analyst, they are going to take our results. They are going to prepare reports or dashboards. If it is data scientist is going to connect our targets, then he is going to predict the future. He is going to write algorithms to predict the features. Okay, our downstreams are either data analytics or data scientist people. Here, let me add one more point here. Let me add one important point. ETL and ELT. ELT. In ETL, we connect sources. We connect to sources. We extract the data. We connect the sources. Then we perform extraction. We don't use data lake. We perform transformation on extracted data. Then we load the data directly into data warehouse. Data warehouse. We load the data into data warehouse. So ETL means extracting data from sources, apply the transformation and load the data into warehouse. So warehouse contain only results. Warehouse contain results. In ELT process, in ELT process, we extract the data from different sources, then we load the data. We load the data into data lake. We load the data into data lake. Once data is loaded into data lake, then we perform transformations using different ETL tools. Then transformed data we load into warehouses. Observe here in ELT process where history of data presented in sources only. In sources only. Different to sources. So, so it is never recommended always connect with the sources. Store that different to sources data into one location called data lake. Our cloud supporting unlimited storages. Our cloud supporting parallel processing. Our cloud supporting both unlimited storage and parallel processing. History of data we are storing into data lake. So all cloud data engineerings, it may be Azure, it may be AWS, it may be GCP, they are following this ELT concept, extracting data from different sources and load that raw data into data lake. If it is AWS, we use S3. If it is Azure, we use Azure Blob. If it is GCP, we use Google Cloud Storage. If it is Hadoop, we will use HDFS file system for storing history of data. On that data, based on the requirement, we are going to perform transformations. Okay. So clear, right, team? ETL and ELT? Yeah. Yeah. Let's start in. As part of Master AWS Data Engineering, let's start understanding what are different data engineering technologies available in real world. So first important one, Apache Data Engineering. We can say big data. Initially, we call it as a big data. Later, big data term is changed to data engineering. As part of Apache data engineering, we have many components like Apache Hadoop, Apache Spark, Apache Kafka, Apache Flink. There are plenty of Apache components are available. And after that, we have AWS data engineering from AWS Cloud, Azure Data Engineering from Azure Cloud, GCP Data Engineering from Google Cloud. And these four data engineering technologies are most popular in real world. And in this four, Apache data engineering components are completely free. You no need to pay single rupee for downloading, installing, using Apache data engineering. All Apache data engineering components are completely free. We have already Apache data engineering components and those are completely free. Then why industry going for cloud data engineering tools? Let's understand clearly, team. If you want to set up Apache data engineering components, we need to use on-prem cluster setup. Cluster means group of machines team, or collection of machines. We need to set up in our own on-prem setup means we can take a data centers, we can purchase hardware, we can install required softwares, operating systems and softwares, Then we have to install Apache Data Engineering Services. We need to configure, we need to manage, administration, everything we have to take in care. So lot of investment. We have other alternative for Apache Data Engineering is we can choose any cloud. We can choose any cloud. Then we can set up Apache Data Engineering on different clouds. Software is free, infrastructure is not free. Software is free, but infrastructure is not free. Every cloud vendor supported Apache Data Engineerings. Every cloud vendor, Azure, AWS, GCP, all these cloud vendors supported Apache Data Engineering components. And slowly, every cloud vendor added their own components. In storage, they have from the beginning, in AWS, they have AWS S3. They slowly, they slowly giving test to different clients for their data engineering services. And slowly, people started moving from Apache data engineering to cloud vendor data engineering services. This is one more because every Apache data engineering we have to set up on either on-prem or cloud. Even though Apache data engineering is services are free, but infra is not free. We have to set up everything. Second one thing, second point. If it is banking customers or healthcare customers, finance customers, they give priority to licensed softwares, not open source and free softwares. Like banking people, finance customers, healthcare sector people, these people gives licensed products, not free and open source product. If it is free and open source, they will try to develop similar kind of product in their organization. Instead, they are giving priority to AWS data engineering, Azure data engineering, GCP data engineering. And slowly, people stopped Apache data engineering components, and slowly, people started using AWS data engineering, Azure data engineering, and GCP data engineering. Many people in my AWS data engineering, they will ask, what is the difference between AWS data engineering, Azure data engineering, GCP data engineering? But all these four, Apache, AWS, Azure, GCP data engineering, purpose is performing transformations on huge volumes of datasets. If we take traditional technologies, those traditional technologies takes hours time to process. Let's say my report want to latest data. Then if you want to display latest data, traditional technologies takes hours of time to get latest data if data size is huge volumes. If you use data engineering, it may be Apache, it may be AWS, it may be Azure, it may be GCP. You can achieve same thing in minutes, seconds, or max of minutes. So data engineering technologies are used in ETL process. Extract the data, transform the data, and load the data for downstreams. Downstreams may be data analytics people, or downstreams may be downstreams may be data scientist people. So in data world, we are first persons to make raw data available for our downstreams. We we get raw data from different data sources and we store it into history like Hadoop, data lakes like Hadoop or S3 or Azure Blob or GCP Cloud Storage. Then we apply transformations. Transformed data again we load into target like data lakes or data warehouses. So I always say AWS data engineer, Azure data engineer, GCP data engineers are heroes. I never compare one hero with other hero team. In my opinion, all these three data engineers are heroes in data world. Maybe process of implementation may be different, but main intention of these data engineering technologies are transform any size of data in seconds or max of minutes to avoid problems associated with traditional technologies. Okay, so all these three data engineerings having good good prior good market in real world. Nowadays, people are stopped using Apache because we have to take in care, set up everything, installations, configurations, and management. Lot of activities we have to take. If you use cloud data engineering, then we least bother about all those things. We focus on data engineering activities. And most of the administrations are taken care by cloud vendors. Only less activities we are going to do, not much activities like Apache components. Let's say if it is Apache Hadoop, we have to set up a cluster, we have to install, we have to configure master nodes, worker nodes, and we have to take recruit a separate Hadoop administrators to make Hadoop cluster available 24 by 7. And it is a fixed cluster. Cloud vendors providing lot of serverless architectures like Glue, Athena, Lambda, etc. These are serverless architecture. Based on your data, it will scale resources automatically. You no need to do. You can just say, I want to minimum these resources, maximum these resources. Based on your requirement, based on your input data, resources are scaled automatically in storage part and processing part. So that's why most of the people choosing cloud data engineering. Yeah, yes, I said we are, we are going to downstreams are these sources. Here data is going to, yeah, here, yeah, sources means source is data. Data going to generate by, data is going to generate by applications, applications and mobile apps, etc. Different applications. Yeah. Let's start in. In this session, as a part of AWS data engineering, let's start understanding what is AWS data engineering. AWS data engineering, we focus on data collection from different data sources and we extract the data and we load the data into data lake and then we apply transformations and we store the transformer data into targets. Let's say data sources may be file systems like different formats like CSV, JSON, XML, Parquet, etc. And data may be presented in different sources like cloud file systems, S3, Azure Blob, GCS, Hadoop file system. And data may be presented in different RDBMS, different NoSQL, different data warehouses. We use data ingestion techniques in AWS Cloud. For data ingestion activity, we have different services like AWS Glue, AWS Kinesis, AWS Transfer Family, and we have multiple data ingestion services. We use to connect sources and we load the data into data lake. So in AWS, preferred data lake service is AWS S3. AWS S3. In some projects, in some projects, AWS S3, we use raw layer, raw layer, and extracted data we load into raw layer. Then we use transformation tools like AWS Glue, AWS Lambda, AWS Athena, etc. Then we apply transformations. Okay. Then transformer data, we are going to load it into stage layer, stage layer. So going to before going to load directly into targets, this transformer results we store it into stage layer. On stage layer, we apply unit testing. Then we check whether results are persisted, are stored, are generated in as expected format or not. Once everything is success, then from stage layer, we are going to move to our targets. Our targets. This is one way of architecture. One way of architecture. Or, or we are going to maintain data lake in this way. So first collected data, ingestion data, we store into raw layer. Then on this, we are going to apply some cleansing, data cleansing, like cleaning null values and changing date formats and changing data types. Then after data cleansing, we are going to move that data into bronze layer, from raw layer to bronze layer. Then we are going to apply some basic transformations, basic transformations. Then we move it to silver layer. Then finally, we are going to apply actual business transformations. Then we move it to gold layer. From gold layer, we are going to move it to targets. Targets. So these kind of data lake environment depends upon the project architect. Just now, one of our friend asked how we get business requirement, and here once we get business requirements from client from BAT, our architect going to design these kind of data lakes. Maximum, maximum suggested architecture is this one thing because we need multiple layers. We need multiple layers. We may require this data somewhere. We may require this data somewhere. We may require this data somewhere. Mostly, this gold layer data is completely transformed data. And this data we are going to move it to targets. This raw layer data is actually we collected from different sources. This is our history data. This is our history data. So we collect data from different sources using different services in AWS like Glue, Genesis, Transfer Family, and we use Lambda to get the data from different sources. We have plenty of data ingestion service and we load the data into data lake. Data lake we use AWS S3. So AWS S3 supports unlimited storage and parallel processing, and it is like HDFS file system. Like HDFS file system, it supports unlimited storage and parallel processing. Yeah. Hmm. Yes. Yes. Yeah. Hmm. Hmm. Yep. So you are saying ELT, one of your question, you are saying you are using different AWS service, and so this data lake instead of S3, you are going to extract the data, you are going to load that extracted data into Redshift. Yes, we can. We can do, and we can use either, you are correct, we can use AWS Redshift, or we can use Snowflake, and these data warehouses also supporting unlimited storages, and these also supporting parallel processing, and we load data directly into this one. Again, we can use AWS data engineering to perform transformation. This is also another architecture. Yes, data warehouse, Redshift. Yeah, let's continue master AWS data engineering. In this session, let's understand what are prerequisites for AWS data engineering. So there are four prerequisites: Linux for AWS data engineering, SQL for AWS data engineering, and Python for AWS data engineering, and PySpark for AWS data engineering. As part of our master AWS data engineering, we are covering these four prerequisites. Okay. First, let's understand why Linux is needed. Let's say if we set up a cluster, let's say if we set up a cluster and we are deploying our applications into cluster. Cluster means group of missions. Group of missions. Let's say this is my prod cluster, production cluster, and application is running fine. But after some days, we got some issue. Then the prod team contacts AWS data engineering support team. Then they have to resolve the issue. So what they are going to do is they are going to give access from one mission. Let's say this is called client to mission, or gateway mission. So we are going to connect to this mission and we are going to find about our jobs, why job is failed, what is the issue, or why job is still running. So most of the time, these prod cluster missions are not only prod, dev servers, dev cluster, testing cluster, prod cluster missions are Linux based missions. Only your developer mission is Windows. So you need minimum knowledge of Linux, minimum, like creating directories, switching from one directory to other directory, reading content of file permissions, etc. Some basic knowledge. So we are going to cover that basic knowledge or Linux for AWS data engineering. How much needed for AWS data engineer? How we can connect? How we can interact? Those knowledge we are going to cover here. Next one, why SQL? Let's say AWS data engineering. AWS data engineering. AWS data engineering solutions we provide in two approaches to. One SQL based and other one is programming. In programming for data related, Python is preferred one. Python is preferred one. So, so data engineering solutions we provide in two ways. One is SQL approach, second one is programmatic approach. So we will try to provide solutions using SQL. SQL is not for every solution. SQL is fixed with all supported commands. It is fixed. So for any problem, programming provides solutions. Any IT related problems, IT related solutions, programming language provide solution for any IT problem. It may be Java, it may be .NET, it may be Scala, it may be Python. I am not saying only Python. Any programming language having a capability to provide solutions. So, data related most preferable language is Python. Why Python? We are going to discuss at the time of discussing Python for AWS data engineering. Okay. So first we will try to achieve solutions using SQL. Whatever the part we are unable to provide solutions using SQL, that part we are going to implement using programmatic approach. So in any data engineering, especially in AWS data engineering, it is a mix of SQL plus little programmatic syntaxes. That's why we need SQL for data engineering and Python for data engineering. Here, as a part of SQL, we are going to discuss AWS RDS. AWS RDS service means AWS RDS means relational database service. Instead of installing different databases, installing, configuring, administration, AWS providing a special service called relational database service. Here it provides multiple databases like MySQL, Oracle, Microsoft SQL Server, PostgreSQL, and it supports Amazon Aurora. You can choose a database which you like, and you can focus on SQL, not on administration, configurations, installations, upgradations, etc. You focus on SQL development. That is the main intention of RDS. So we are going to discuss RDS with SQL. Okay. In RDS, we are going to set up a MySQL server. Then we are going to implement SQL concepts on RDS. And along with this one more prerequisite PySpark for AWS, AWS data engineering. Why PySpark is needed? Let's say In AWS, we implement ETL concepts using one special service called Glue. One special service called Glue, AWS Glue. So AWS Glue providing drag and drop solutions. You can just drag source and drop source, drag transformation, and drag target. Let's say S3 is my source. You can just select drag S3, and transformation is a filter transformation. You can just select a filter transformation, and target is Redshift. You can just drag that service name. You just modify properties. Just modify properties. That's it. Once you drag and drop, it will generate a PySpark code in the backend by default. It will generate PySpark code in the backend. Second one, if you want to understand this generated code, if you want to understand this generated code, you need minimum knowledge of PySpark. Second one, if you want to modify, let's say you are not satisfied with the generated code, then you need knowledge of PySpark to modify. That's fine. We are also covering PySpark for AWS data engineering as part of our course. These are four prerequisites needed for AWS data engineering. We are covering these four prerequisites as part of our course. If you already having, it's well and good. But if you do not have also, I am covering as part of this course. Okay. Yeah. Let's understand uh, who can learn AWS data engineering. As part of master AWS data engineering, let's start discussing who can learn AWS data engineering. So first one, let's say you want you build your data career, or you want to start a career in data world. It is recommended to start data engineering. In that, start AWS data engineering because it has lot of openings compared to other data engineerings. Many projects are implementing using AWS data engineering. Next one, too. You are a uh, you are a let me spend spend. Let's say you are already having experience. Let's say programming experience. You are a programmer, maybe Java, or maybe .NET, maybe .NET, or maybe Scala, or maybe Python, maybe Python. You are having a programming knowledge, or or you are already having exposure into SQL field, SQL field. Maybe data warehouse engineer, data warehouse engineer, or maybe you are RDBMS developer, RDBMS, maybe MySQL or PostgreSQL or Oracle or reporting tools like Power BI, Tableau. You have a good knowledge of SQL. Then you may having any SQL knowledge, maybe DBA. Then I always recommend data engineering. And especially, I recommend people who are from SQL background. They have a full or good SQL knowledge or strong SQL knowledge. I said most of the time in AWS data engineering, we provide solutions using using SQL. So 80% plus we will use SQL plus string. That's why even if you are a fresher, you can easily learn data engineering. Learning SQL is very easy. Learning SQL is very easy. So if you are a programmer, learning AWS data engineering is very easy. If you are a SQL based developer, maybe reporting tool, maybe data warehouse, maybe admin of data warehouse or RDBMS, you have a strong knowledge of SQL, you are the first person to learn data engineering because you are going to provide best solutions for data engineering. Okay, so you may be coming from testing background, you may be coming from non-IT background. Learning SQL is very easy. So first, I suggest you can focus on once we complete our prerequisite of SQL, then start building SQL knowledge, and parallelly you can start building Python programming knowledge. I am going to cover how much needed for our data engineering. Once I complete, no need to join Python classes, no need to join SQL classes. Start exploring through internet, or nowadays we have GPTs like ChatGPT, Perplexity, plenty of GPTs available. You can go with any GPT and increase your SQL knowledge and programmatic knowledge. These two are mandate for AWS data engineer. So we are covering prerequisites. We are covering prerequisites. Uh, that is more than enough. Okay. Or you are working in different technology, you want to switch to data engineering. AWS data engineering is having good openings, good packages. I'm not comparing any other data engineering tool stream. Every data engineering having their own advantages, their own disadvantages. There is no software technology having all advantages. Every software invented to solve problems of existed, and new software invented to solve problems of this software. So every software having advantages, disadvantages. So compare, I never compare AWS data engineering with other data engineerings. My opinion, all three popular data engineerings, AWS, Azure, GCP, in my opinion, all three data engineerings are heroes because nowadays data engineering ruling because of these data engineering technologies. As a AWS data engineer, I always suggest go with AWS data engineering because it has lot of openings. Other than that, I never compare one data engineering with other data engineering. You want to start your career, then start. If you already having a experience of this one, this is add an advantage to enter into data engineering skill. Still, you want to move. Then after this, you focus on data science. After this, you can focus on generative AI, Gen AI. So I always suggest who want to become data scientist or generative AI. I always suggest this is the correct path. Learn programming or SQL, start your career, then jump into data engineering, and then jump into data science, then jump into generative AI. But I say you never get a chance to go out of data engineering. because you will get to so many projects. If you do not have a feature, then we will jump. If people are not given good packages, we will jump. Yes or no? So data engineering having lot of openings, and data engineering people are getting high packages compared to other technologies. So if you have a plan, then choose this kind of career, or uh, from your existed career, you can jump into AWS data engineering. Or if you are a fresher, start data side first. Only one thing, once our prerequisites are completed, start increasing knowledge of Python, start increasing knowledge of in-depth knowledge of SQL once you complete our course. Because I am going to cover all the concepts of Python and SQL. Once completed, then start exploring and increasing knowledge. Then, then you can provide solution for any problem in data world. Clear, right? Yeah. Let's start in. As part of Master AWS Data Engineering, in this session, we are going to discuss AWS Data Engineering hands-on demo or live hands-on demo on AWS Data Engineering. So with this hands-on demo, you are going to understand how we are going to work with AWS projects. Let's say you are coming from other uh, programmatic programmatic knowledge or other technologies, or you may coming from non-IT background. You have a question about how we are going to work in AWS environment. Is it require any special softwares? This demo gives clarity how we are going to work. No need to know any of these services details. Just understand the flow, how we are going to work. Okay. In this, first I'm going to start with storage service called S3, then processing service called Glue, analytical service called Athena. As a developer, let's say this is me, Sreenivas. I am going to upload file into S3. On this file, I am going to create a crawler. This crawler going to store information about this file, file type, file location, and columns of file and data types of file called metadata or schema. So this crawler going to store metadata information. Then Athena, here I am going to write SQL queries. Then this Athena going to read schema or metadata. Based on that, it is going to read data from this and going to display results in Athena editor. Okay, let's start implementing this floating. First, you need to have a AWS account. You need to have AWS account. I already having a AWS account. I already having a AWS account. I already logged into my account. So first I am opening AWS S3. In this AWS S3, we are going to create a bucket. No need to know what is bucket, what is bucket, what it is going to do. In AWS S3, we are going to discuss this entire process in depth. Here we have a create bucket. Then I am going to create a bucket. So here I am giving bucket name, let's say Sreenivas hyphen live hyphen hands-on hyphen demo. Sreenivas hyphen AWS DE hyphen live hands-on demo bucket name. Then here I'm checking public access. Then I'm clicking I acknowledge. Then I am creating bucket. This part of it. So this part, first step, I am performing. Okay. Then once bucket is created, in this bucket, I am going to load the file. Let's say here we have a upload. I have all files under C drive, under datasets. Let's say S3. This file I'm going to upload. Just drag this file, place this file, then click on upload. Or let's say I recommend create a folder. Folder name EMP or employees. Okay. Then create a folder. Let's say place this EMP file. Then click on upload. Under bucket, we can create a folder. In the folder, we are uploading file. First part is completed. This first part is completed. We created a bucket, we created a folder, and we uploaded file. Now I want to create a group caller to access this file. In AWS, this is service 1, this is service 2, Azure. One service want to access another service. By default, it is not possible. A service cannot access another service. Then what is needed? We need a permission. We need a authorization. We need a permission. So in AWS, there is one more service called AWS IAM. IAM stands for Identity Access Management. Here, we are going to create a role. For this role, let's say role 1, we are going to attach S3 access. S3 access. Then we are going to attach this role to our crawler. Then crawler having permission to access S3. Similar way, Athena also we are going to attach IAM role. Then it has access of S3. Okay, clear, right? So for authentication and authorization, we use AWS IAM. Let's see. I am going to perform these two steps at a time. Usually, first we do this one, 2.1, and later we are going to do 2.2. Okay. In this step, instead of confusing AWS IAM, AWS Blue, in a single step, I am going to perform. How I am going to perform? Let's see practically. First, open a service called Glue. In search bar, you can type Glue, then open a Glue. Open a Glue. In Glue, you can see 3 bars. Click on this one. This opens AWS Glue dashboard. In left side, you can see crawler. You can see crawler. Click on crawlers. Here you can see create crawler. Click on create crawler and give a name to crawler. Let's say I am giving emp underscore crawler. emp underscore crawler. Description is optional. If you want, you can provide. Then click on next button. Then, then here we add this S3 location. In crawler, we will specify S3 location. So here add data source. Click on add data source. So here data source is S3 and select S3 path location. Click on browse and click on this one bucket. Under bucket, click up to folder location. That's it. Place cursor here and then click on add S3 data source. Then click on next button. Here we need to choose a IAM role. So if role is already created, we can choose, or you can create a new role. Create a new role. Create a new role. Give a role name. Let's say hands-on demo. Then click on create. Okay. Then click on next button. Select a target database. So here I said it is going to store definition of this file. So to store definition, we need to create a database. We need to create a database and we need to provide this database details. Okay, let me open a option to create a database. Let me open another Glue terminal. In this Glue terminal, you have a option of creating a database. See, databases. You can create a database, or here we have option of add a database. Again, it is going to open this one only. Okay, click on add database, then type hands-on demo db, hands-on demo db, then click on create a database. It is created. Go to our uh, uh, crawler creation. Just refresh here. Then select this hands-on demo db. Then click on next button. Then click on create crawler. See here, go to this database. Right now, there are no tables. Once we run this crawler, then go to crawlers, go to once again crawlers, refresh. You can see crawler is running. Once crawler is completed, it is going to connect S3 location, reads the file, identifies column names, reads sample data, identifies data type of each column, then stores that information. Let's wait to complete this crawler execution. Yeah, crawler is completed. Let's go database, refresh, here, refresh here. You can see table is created. Table name is employees, database location. This is file location and type of that file. Then click on this file. You can see list of columns. Let me open that file, EMP file. So these column names, and based on this sample data, it identified data types. Okay. So these two parts also completed. Sorry. So blue craft, sure. Yeah. So whatever the location we provided, in this location, it read file. It folder may contain one file or multiple files, but we store same type of files, right? Same concept, same data. Okay. Here we created a folder called employees. We store employee files only. So based, yeah. Now let's continue writing Athena queries, means SQL queries in Athena editor. Let me open uh, Glue catalog contain only definition, actual data presented in S3 location. Yeah, metadata. Yes, yeah, correct. Yes. So it contained complete meta information. Means so table name and file location and column names, and each column data type. Now I am using Athena editor. In this Athena editor, you can write query data using any of this one. Let's say I'm selecting Athena query editor. Here, in this, we write SQL queries on S3 file. Observe here, it is selected databases. So we created database using Glue. Then we got the database information. Once you selected, you are seeing table name. Then you can write select query. Select star from employees. Yeah. No, I am going to explain the process. Let's understand first how we are reading S3 data using Athena SQL query, and later I am going to explain clearly. Okay. See here, I am writing SQL query, select star from employees. We may get one error. That error is related to logs. You are executing query in Athena, but where logs are going to load, we have to select a location. Here we have a edit settings. We can select a location for Athena queries. Without these settings, let me run. Click on see. If I want to execute here, run button is not enabled because log location is not created. Just select any one location. So here, go to edit settings, go to edit settings, or go to query settings. Okay, here editor, and you can click on this one, click on edit settings or query settings. You can select query results encryption. Then location, select the location, browse location. Let's say any location. Let's say select this one, click on OK. then click on save, then go to editor. Now you can see run button is enabled. Select this one, then control enter. You can see output here. So total 11 records. Let me explain what happened here. So first one, this is my S3 service. S3 service. In this S3 service, I have a bucket. Under bucket, I have a folder. Under folder, I have a file. I have a file. This file is CSV file. Then here I'm using Athena. I'm using Athena. Using Athena, using Athena, I am writing analytical queries, let's say SQL queries on top of this S3 file. File is in CSV format. It is a file. On top of file, you are writing SQL query. How Athena knows about columns information, and data types information, etc. So here there is one concept called AWS Glue Data Catalog. AWS Glue Data Catalog. AWS Glue Data Catalog. Catalog. Here we are going to create a database. In this database, we are going to create a schema for your input file. Schema means metadata. How we are going to create this schema is AWS Glue. AWS Glue having a concept called crawler. AWS Glue having a concept called crawler. So we will create a crawler, AWS Glue crawler. This glue crawler, we are going to give a input location. So to access this file, we are using AWS IAM, and we created IAM role. Then we attached this IAM role to crawler. Then crawler read this input file and stored information of your input file, means file name called table name and file location and column names and each column data type. Then if we execute SQL query in Athena, it is going to read that definition, and based on that it reads input file, then we are getting output. Clear, right? What happens in this hands-on demo? Yeah. So first one, this is my input file. Input. In this input, we are writing SQL query. So for this SQL query, you need to have information about columns details, data type details. So to store that meta information, AWS providing Glue crawler. Using Glue crawler, we are creating a connection to S3 location. It has a logic to read different files like CSV, any other formats. Then reads a file name, file location, and go to that particular file, identifies column names, identifies data types, and stores that meta information into Glue catalog. Then whenever you write SQL query in Athena, it is going to connect this data catalog, reads a schema. Based on this schema, it is going to read data from this file and displays output for us. Okay. Yes, correct. Yes. That's why, that's why if you see here, we executed, we executed crawler first, then after that in Athena editor, you are going to see all, all tables list here. Database, it will list databases in Glue data catalog. It will list each database table. That's why we are able to write query and we are running that query. We are seeing output. Okay, clear writing? Yeah.